Hello friends, in this video we are going to look at our first collection, ArrayList. ArrayList is a collection over a resizable array. So before we move into ArrayList, we will look at the list interface. So list interface deals with the concept of object in a sequence and position. Sequence in the sense object is arranged in a continuous memory location in the heap. So that forms a sequence. Then each object will have a position. Since list is position based, the developer can specify where they want to store their object through the index. So by specifying the index, they can store the object at particular location, and the same way they can pick an object from a particular index location. Like arrays, the index is 0 based. That means if you want to pick the first element, then we will be supplying the index as 0 to the corresponding function. The list allows duplicate values, including multiple null values. This means you can store same object multiple times at a different location. ArrayList and linked list implements this list interface. There are other collections also, but in this video series we are going to look at ArrayList and linked list and see how it implements the list interface. So the ArrayList is part of java.util package. ArrayList, as the name suggests, a list implementation over an array. Means ArrayList implements the list interface. Here are the some of important methods. So you can add an element. You will be supplying the element, then calling the add function. So for the add function, element is the parameter, then the element is added to the array list. Then you can make a call to remove method by supplying an object element. So what ArrayList will do, it will search its collection, then it removes the very first occurrence and returns true. So if it finds the element, it returns true, and if the element is not there in the collection, then it won't return true. The clear function clears all the elements and keeps the array list empty. This empty function will tell is there any element in the array list. The size will return number of elements currently stored in the array list. Contains method walks through the array list and tells the parameter object who is present in the collection. So you can supply an object and test whether that object is a part of the array collection. I mean array list collection. So from ArrayList we can retrieve the iterator. We will look at iterator in some other video. Here in this example, we are not going to look at the iterator. We will look iterator in some other video. When user adds element to ArrayList, the underlying array will be resized if it is required. Say for example, the array size is 10 and all 10 slots are filled, and when you are calling the add method, so to accommodate that new incoming object, the array will be resized. So we don't need to worry about resizing the array, it will automatically get resized. When we add or remove element, ArrayList elements are adjusted. That means, as already told, ArrayList is a pack of a continuous memory. So when you add a new element, the existing elements needs to be adjusted so that the new element can come and sit in the location. Say for example, this is our existing array E1, E2, E3, E4 at index location 0, 1, 2, 3. Suppose if we want to add an element at a location 2, let's say we want to add an element at a location 2, what happens? The elements at position 2 and 3 are shifted towards right. Then new element is occupying that free space. So after this adjustment, the indexes look like this. So if you look at the element 2 and 3 is shifted towards right. So that's a copy operation. After that, a new element C1 is created. So after this, the array looks continuous. So the C1 element is at index location 2. E3 is at new index location 3. Previously it was at index location 2. The same goes for the E4. The previous index location was 3. Now it is at E4. Picking an element is quick. Because here, since it is a continuous memory location, when we want to take an element based on the index, it will be easy. Why? Because the memory is continuous. So we will be reaching to that memory location more quickly, and we can get that element. The array lists are suitable for multiple read and minimal writes. That means multiple read in the sense, since it is fast when we are reading the element, so the array list is suitable for frequent read operation. But if you think that this data structure contains more write operation in your programming, then ArrayList is not suitable, because writing in the sense adding a new element or deleting an element. So delete is not a write operation, but it's kind of manipulating the array. So this manipulation is slower here in array. Why? Because it needs to adjust the memory slots to maintain the continuous location. So that way the write operation or the manipulation is slower, but the read operation is faster because of this continuous arrangement. In ArrayList, adding and removing is a costly operation, as it involves copying the object and reindexing. Retrieval of element is quickly done as index is specified. So index is specified, and at the same time the memory is packed continuously. So this will help retrieving the element more quicker compared to linked list that we will see in the next video. Alright, now let us explore this in Eclipse. So here is the class. The product.java contains a class definition for a product. it has two members. One is a product ID and product name, two data member. Then the constructor will initialize the product. It takes int ID and a string name. Then it initializes the internal member. Then we have a string override, and in that override we are formatting our internal members so that the product can be represented as prod ID colon product name. Next we have getter and setter for the internal members. That's all in the product class. Now let us look at the ArrayList test.java. Here what we are doing, we are actually creating an array list. Within an angle bracket we specify product. So this is a strongly typed array list, and this list can store only the object of type product. Then we specified products, which is the reference, equal to new array list of product. So this is how we create our collection object. Then in code snippet 2, we are creating 4 instances of our product class: pen, pencil, rubber, and writing pad. So we give a ID, then we give a name in the constructor so that we can construct our object. So at the end of code snippet 2, we have four product in hand. After that, what we do, we are adding these 4 products to our collection. So at the end of code snippet 3, our collection will have 4 products. The collection name is a product if you look at the plural form, and it stores 4 products for now. Next, what we are doing, we are printing the product. We are passing the reference products to that function. So at the end, if you see here is the function print products. The parameter here is ArrayList products. So what we are doing here, we are iterating through the product. You can look at the for loop construct. So this is kind of a for each form. We are iterating over the products collection, which is in the right hand side of the column. Then in the left hand side, we are having the product. That means in each iteration, we will get 1 product. So we are iterating over the collection products, and in each iteration, we will get 1 product. And inside the loop, we can refer that product. So what we are doing here, we are printing that product. So we directly specify the reference name prod in the line 47. So what happens, it will make a call to the toString function of the product object, and it prints that formatted output there. Right, so this goes for 4 times in this example because we have 4 product in the collection. So the loop runs for 4 times and it prints the product detail. So that's what happens when we call print products. So at snippet 5, we will be printing all 4 products. So we looked at the collection function add at code snippet 3. In code snippet 6, we are removing the product. If you look at here, we are passing the reference to P2. That means we are asking the collection to remove the product 102. That means the product ID here I am saying 102, or the name is pencil. So what happens, the Java framework will visit the objects in the collection, and when it finds the node P2, it removes that element. That means it removes the pencil element. Next, what we are doing, we are asking to print the products once again. So now it will print 3 products. After that, we are adding the product in the same location. We are adding the same product P2 in the same location. Here you can look at how we invoked the add function with the index notation. So previously at code snippet 3, we just called the function add and we provided the reference to product. So what happens, it will add the product towards the end of the array list. But here we are actually plugging the new product at a specific index location. Since we specified the index location in parameter 1, here it is 1. That means we are plugging the product in between, and here the operation is costly because it needs to adjust the element that comes after this index location 1. Alright, so at code snippet 7, what we are doing, we are making use of the contains function. First, what we are doing, we are passing the reference P4 and we are checking whether product collection contains P4. Here products is the ArrayList collection and we are checking whether the ArrayList is having the product P4. That means we are checking whether a writing pad is there in the collection. So when it returns true, we are printing writing pad is in the collection in the console output window. So this is one example. In the next example, what we are doing, we are creating a new product called rubber. And if you look at here, the ID for the product is 103 and name of the product is rubber. And if you see here, even though the reference is different, previously we are holding a reference to P3 that also has a product with the same 103 and rubber. Here we are constructing a new product in the heap, but the content is same. So now if we pass this new product to the contains method, the ArrayList should check the collection and it should return true because it has a product with ID 103 and with the name rubber. Right. So here our expectation is that both the if condition should evaluate to true and it should say writing pad is in collection and rubber is in collection. So in the final part, what we are doing, we are clearing the list. Then we are making use of the isEmpty function also. Since we called products.clear, it will remove all 4 elements. Then the isEmpty function will return true. That's why we print that ArrayList is cleared. Okay, now we will debug and see how it works. And if you see here, we will get one logical error and we will rectify it later in this same video. First we will run this with a breakpoint so that you will get a more picture. Alright, let us go to the variable window. Here what we are doing, first we are creating the array list. And if you look at the array list is empty at present, or I can click here and if you see the array list is empty. Next, what we are doing, we are creating 4 objects in the heap. You can look at here, P1 is created, P2 is created, P3, P4. There are 4 objects created. So these are all the 4 objects in the heap. But this is not yet added to the list. Now we will add it to the list. I mean the array list. So okay, it's already highlighted. The product array list is highlighted. It is empty at present. When we execute each line here, you keep a watch on this particular content, I mean the product array list content. So first I am adding the product P1. P1 is already there in the heap. Now I am adding it to the array list. So now array list contains 1 element. I am adding 1 more, and if you see, it will get added towards the tail end. So pencil is added, then rubber is added. After that, writing pad is also added to the list, I mean the array list. Next, what we are doing, we are printing the product. Let me step into it, and if you look at here, we are iterating through the list. Since it's a console output statement, you can keep a watch here. So it prints 101, then it prints the second product detail, then it prints the third one and fourth one. That's all. Here is the content of our array list. At present we have pen, pencil, rubber and writing pad. So let's clear the output. Now what we are doing, we are removing the element at index location, by giving the reference P2. So the P2 is actually product 102 pencil, which is here at the first index location. This is 0th index location, this is first index location. So once we call remove, the particular element will get removed from the array list. So this is our new array list now. So if I print product, it will print our new list. So this time I will execute it directly so that you can see that in the console output window. Alright, now we are adding back the element. This time we are specifying the index location 1. That means this is 0th index. First index is here. So the P2 is a pencil that get added here. So once it get added here, these 2 members needs to be adjusted towards the right to maintain the continuous memory location. So now I am adding it back, and if you see, this is our new content. Now what we are doing, we are checking whether P4 is inside the list. If you see, here is the P4, which is 104 writing pad, and it is in the list. So now when we execute this, it says that writing pad is in collection. Now we create a new instance rubber, and if you look at here, rubber and P3 both are same. Why? Because the heap location here at ID 49 has an object with product ID 103 and product name rubber. So the new heap location ID 85, because here we created a new product, contains the same content. Product ID is 103 and product name is rubber. Now what we are doing, we are passing this new location ID 85 to our collection, and we are asking the collection check and tell me whether rubber is there in the collection or not. Previously we passed the reference P4 which was added to the list. So when we added that, the list and P4 both refers the same memory location, but this time the memory location is different. If you look at here, this is rubber, ID is 49. If you look at here, this ID also 49. That means both refers the same memory location. But here, if you see, this memory location is different, but content is same. Product ID is 103 and product name is rubber. So the expectation is that the array list should tell us that rubber exists. So that's the logically correct way of informing. But what happens here, it doesn't say that rubber is in collection. Alright, we will rectify this now after we run this. Now we are clearing the product. Let me highlight the product. We have 4. Once we call clear, the list goes empty. Here you can see the list is empty. And now when we call is empty, it will return true. That's why we print array list is cleared in the console output window. Alright, here we saw a failure, right? So this one get paused. This if condition get paused previously, but the next if condition is failed. Now we will go here. So to avoid such an error, what we have to do, we have to override the equals and hash code method. Here for this example, overriding the equals is enough. But as per the Java standard, when we override the equal, we should always override the hash code also. So how to override equals and hash code is already covered in the video series. You can look at the initial video when we talk about the object. There we have shown how to override the equals and the hash code. The same way here we overrode those functions. Now what our equals method tells is how to compare the product, how to compare two product. So here what we are doing, we are casting the incoming object as product. Then we are saying two product are equal when their product ID matches. Even if name differs, we don't care about it. What all we care about is the product ID. When product ID matches, we say that two objects are equal. So we know that these objects are added to the collection. So here in our example, we added this product to the ArrayList collection. And when we invoked the contains method, it failed. Why? Because it doesn't know how to compare two product. So what it did, it gone with the default implementation of the equals. That means the implementation which is done in the object level. So the object level implementation compares only the memory address. So that's all it knows. It just compares whether two memory locations are equal. When it is equal, then it says two objects are equal. Here, since we defined our product, we very well know that when we can say two product are equal. So that's why we have to override the equal method. Now the collection, when it want to compare two objects, here when we go to contains method, it actually compares the object, right? So here we created a rubber. it's an object, and this object needs to be compared with existing object. There are 4 objects. So now what happens, since it knows how to compare the object, it walks through each product, and when it compares this rubber with P1, it knows that it should compare the ID. So 101 is not equal to 103, so it says the object are not equal. So when the contains method continues like this, it reaches the particular location, and then it knows that the object in the collection is equivalent to the rubber by comparing the ID. Alright, so to show you, I will keep a breakpoint here in the equals method, and you will come to know what happens. So we will go straight to the point. This one we know anyhow, it will pass. Alright, even for remove method, if you see, it called our function. Why? Because it needs to compare, then it should remove. So for now, let me remove this breakpoint. We will reach till this point. After that, we will enable it. So we are here, now we will enable. We'll go to variable tab. So a new product is created. Now we are making call to the contents method. ArrayList.contents we are making call. It is going to make use of our equals method to tell the result. If you see here, this object is our collection, and incoming object is the pen, 101 pen. This is 103 rubber. This is not equal. If you look at here, it is making call to our function, and here we are comparing only the product ID. So it will return false. Now it iterates over the second. It's comparing with the pencil. So the rubber is fixed here. This is coming from our array list. Now comes rubber. So now it found rubber is there. So what happens? We return. So we return true, and this time it prints rubber is in collection. So if you see, it used our method here. Now it knows how to compare. Previously it just compared the memory location only. That's why when it finds this rubber, and this is also rubber, so the ID is 38 here, the ID is 40. So it said that rubber is not in the collection. Now we asked it not to compare this memory location. Why? Because Java object compares that's the default implementation, compares the memory location. Here we overridden that object method equal, so that's why it makes use of our equals method and tells that the object rubber is there in our collection by comparing only the ID. So here it says now we see writing pad is in collection, which is right, and rubber is in collection, which is also right. So now we are seeing this rubber is in collection after implementing the equals method. So at present this array list is using this equals method, but whenever you override the equals method, you have to override the hash code also. Here if you see, we just returned, we are making call to hash code from the objects class, and we are passing only product ID. Why? Because here our equals method uses only the product ID member. That's why we involve only product ID when generating the hash code. So if we used both product ID and product name, then our hash code should include both product ID and product name. You can actually pass a comma separated list of parameter to this hash code. So it finally, this hash code will combine all the parameter and generates a hash code out of it. Hash code is an integer type. Alright. The collection will use this hash code also. We will see that later when we are proceeding with the video series. Alright, that's all here in the Eclipse demo. We will switch back to our development perspective. Yeah, so that's all in this video. Thanks for watching. Bye. Alright, so if you like the video, please subscribe the channel. Bye for now.